Hi, I'm Danny. I'm from Monash University. In this presentation, I'm going to introduce a sorting algorithm. Think about it. What is a sorting algorithm? If there is a list of numbers, we will sort it from the smallest to the biggest, or from the biggest to the smallest. And if it is a list of letters, we will sort it alphabetically. There are many kinds of sorting algorithms like inserting sort algorithm, selection sort algorithm, and merging sort algorithm. I'm going to introduce is called a quicksort algorithm. And later I will introduce example to present the procedure of this algorithm, and then I will talk about the invariance of this algorithm, and finally we will discuss the factors affecting the time of this algorithm. Okay, let us see this example. Generally, we get a list of number. What we need to do is find an element called pivot. Whatever the element is, you can use the first number, you can use the last number, also you can use the middle number. But it's whatever you want to use, but it must be random. And after we select the pivot, we need to separate this whole list into two parts. We put a smaller number. We put a number smaller than the pivot to the left part, and put the number bigger than the pivot to the right part. And do it repeatedly again and again until we find a part just contain one list as a whole part just contain one element, and we merge them together, and finally we will get the sorted list. Okay, let's do it. I will use last element as my pivot. Okay, the last element here is 5. I use this 5 here is a pivot, and put the smaller number left side. We will find 6 is bigger than 5. Okay, put 6 right side. 2 is smaller, 8 is bigger, 7 is bigger, and 1 is smaller, 4 is smaller, 3 is smaller. And do it again. Find the pivot. Pivot here, I will use 3 as my pivot, and put a bigger, and compare with them. We find 2 is smaller, 1 is smaller. Okay, and 4 is bigger. We put 4 here. And still about this, we choose 7 as our pivot. We find 6 is smaller, 8 is bigger. Okay, we still have 1. Okay, we use 1 as our pivot, and the 2 is bigger. So here, okay, we start to merge them together. This part we got 1, 2, 3, 4, and this side we got 6, 7, 8, and then this part with this part and this part together, merge them together. We finally got 1, 2, 3, 4, 5, 6, 7, 8. That's the final answer of this list. And then we try to find the invariance of this algorithm. Think about what is invariance. Invariance is a condition that is always true, necessary true, no matter what it changes, and no matter it will change. And we find it. Every pivot, the left side of this pivot is smaller than this pivot, and all the element of right side is bigger than this pivot. and we find this is meet the consideration, and this also meet this condition. So the invariant of this algorithm is the left side part of the pivot is always smaller than the pivot, and the right side of the pivot is always bigger than the pivot. And finally, we start to discuss the factors that affecting the time. In this algorithm, we will find the complexity. What is the complexity? Is the total time it uses. Okay, that this thing is a level. It's called one level. Is this? This thing is called a level. This thing is called a level. And every level will do n-constant operation. So n times the number of level. And in the January, ideally, and as we expected, we need the best condition is the number of level is log n here. That's the best and ideally condition, but it can't be always the condition you want. There are some conditions you don't want, like if we always choose the smallest number as our pivot in the list, we will get n times level. So still n constant operations times n level, we will get n squared. So that's very big. Think about what is a big factor will affect this time and the complexity. Is although the length of this list is an important factor, but also the pivot we choose. The pivot we choose is also the big factor, will affect the time of we will use. Well, also, okay, and finally, this is this presentation, and after this presentation, we know the procedure of this algorithm, we know the invariance of this algorithm, and also the complexity and the factors affecting the time of this algorithm. Thank you.